11.
Like 30.
Okay. No, that's okay. Recall that acceleration due to Earth's gravity is 32 feet per second squared, but we said really we're going to make that negative 32 because it's falling down to Earth, right? Right. Thank you. From ground level, which means my initial position here is 0 because I'm shooting from the ground. From ground level, a projectile is fired straight upward with velocity of 90 feet per second. That also tells me that my initial velocity is 90 feet per second. So I got a lot of information from that one little sentence there, two little sentences. What is velocity after 3 seconds? So I'm looking for the integral from 0 to 3 of acceleration, right? Or I could just find the, and that might be easier for you to see. If I just did this and found the equation for velocity, which would be negative 32t and then plus 90 because that's my initial velocity. Does that make sense? So now what is the velocity after 3 seconds? Well, I could just plug into that equation that I just made. Didn't what? What are my units for velocity? Feet. All right, part B, when does it hit the ground? So that I need to know position, right? And I want to know when is position 0. So now I need another equation. I need the antiderivative of negative 32t plus 90. That's going to give me position. So I get negative 16t squared plus 90t, and it told me that my initial position was 0. If I put the plus c in here and I did 0, 0, I'd find that c was 0. You sure? So when does it hit the ground? So I need to know when is position 0. I just factored on this one. Or I would just factor on this one. What can you take out there? Can you divide 90 by 16? We'll just take a t out and see what happens. Negative 16t plus 90. So now, obviously, t equals 0 is one solution, right? Because that's whenever it's fired out. That's whenever it starts. This is the solution that I'm interested in because that's whenever it loops back around and it hits the ground again. Are y'all following me? Is this a problem? So, negative 90 divided by negative 16? 5.6. What are my units? It said, when does it hit the ground? Second. For 5.625 seconds. When it hits the ground, what is the net distance it has traveled? That means displacement. Well, this you really didn't even have to do any work for, right? Why? If it went if it went up this much, but then it went back down the same amount, it's back where it started. So what's the displacement? 0. Does that make sense? We're not talking about this. We're talking about up versus down. Right versus left. Right? Go with me. And then part D, when it hits the ground, what's the total distance that is traveled? So I'm looking for total distance traveled from what to what? 0 to 5.625. So how do I do total distance traveled? Absolute value of velocity, right? Are y'all with me? So velocity, I have this equation. So I want the integral. And by the way, this is always positive, right? Agree with that? So I don't even have to split up the interval. 0, whoa, 5.625. Was this a calculator problem? Yes, it was. I put this on my calculator for sure. Plus 90. Should get 253.125 feet. If y'all need me to do it, tell me. Okay. Yeah, graph it, make sure you can get the same thing. Got it? All right, what else on your homework? That was 11. All right, let's do 15 and 16 more. Yes, this is where does the particle achieve its greatest positive acceleration? And so I've got this little picture here, right? And I have these values, and this is A, this is B, and this is C. And this is the graph of velocity. So first I have to think, what relationship does velocity and acceleration have with each other? Anybody? I feel like Ben Stein up here. What's the relationship between velocity and acceleration? Acceleration. And derivative means what graphically? Slope. So if I want the greatest acceleration, then I want the greatest slope. And it says positive, right? When does it achieve? But it says only between A and B. Nope, I lied. 0 and B. 0 and B. So where's the slope the greatest there? Greatest positive. It looks like, yeah, if I keep doing some tan lines here, the greatest slope is going to come in right around here. And then 16 says, where does it achieve its greatest positive acceleration between 0 and C? Well, if you look at C compared to A, my graph is not quite as accurate as theirs. This one shoots up a lot faster than does this one. So this one has a more positive slope. So it has a greater acceleration. And then what'd you say, 25? 29. Hot dogs. I haven't even looked at this one, honestly. Okay. A popular hot dog stand opens at noon. At different times between noon and 3 p.m., the store manager stops by to measure how fast the hot dogs are selling with the results given in the table. Use a trapezoidal approximation to estimate the total number of hot dogs sold during the first 3 hours. Time in minutes. Well, first thing is how many minutes. Oh, that's all. Yeah, so we're just going to do trap rule then. Remember how to do trap rule? So it's 1/2 height times base 1 plus base 2 for a trapezoid, yes? And so I'm going to do this each time. I'm going to do, so my height, if you look, these are each going by, oh, I'm not going to be able to do it. I have to do individual trapezoids for each one. I can't just pull this H out on the outside because it's not a constant H. If you look, the first two, there's 10 minutes between, then the next two is 20 minutes, then the next two is 15. No. You just got to do different trapezoids. So, here we go. The first two go between 0 and 10, so that's 10 over 2 times 3 plus 6 plus. Next two are 20, 20 over 2, 6 plus 18. 15 over 2, 30 to 45. 18 plus 16, 45 to 60 is another 15. 16 plus 12, 60 to 90 is 30. 4 plus 8. 90 to 120, 30. 8 plus 10. Y'all see where I'm getting these numbers? 120 to 180, 60. 10 plus 6. That should give you 1800. Does it? So 1800 volts. Y'all seem to have taken pretty well to this. Yeah. This section. No? You lost on this one? On this section? Not this week. Thursday's your, oh, you weren't here yesterday. Thursday's your quiz on your derivatives and integrals. Yeah. You're gonna be what? Oh, they're in the front office. Yeah, I told them that your mom was coming to get them, but yeah. They're sitting in there, they're behind the counter a little bit. Miss Patty will give them to you. She's guarding them so nobody eats them. Well, obviously I put a few extra in there for your mom, so she would, yeah. There's a few more than what she ordered. Take a picture of them if you do, because I forgot to take a picture. And I think they look cute. Yeah, I think they look cute. They look really good. Okay. Well, it's for a guy retiring, so it's kind of hard to come up with like a generic guy thing. But they got like a cross hatch on them, and then KCSD, and then congrats. But I just thought that, yeah, they're kind of generic but good. What else? What else? What else? That's it. I have to try to decide. Oh, Stacey. We're literally 2 sections out from being done. We're in Unit 8. Position velocity acceleration, that's your PVA. Using accumulation functions and definite intervals and applied, that's your word problems. We're doing area between curves as expressed in terms of X. Tomorrow we'll talk about in terms of Y. We'll camp out here for a couple days, but then this is all volumes of revolution, which is one section. No, don't give up. This is the fun part. Yeah, we'll be the rest of this week on this section, I'm sure, because Thursday we're doing that quiz. We might be able to touch a little bit on area, on revolution. What makes you want to give up? Why? You asked for it. I did not want to. It'll be good for you, though. It really will. It'll force you to learn it. It's just that. It'll just be straight memorization of that. The pink sheet, the whole derivative side of the pink sheet, and then the top rectangle of the integral part on the back side. Like I'm literally just going to copy and paste, but I'm going to erase the what follows the equal sign.
The top part of the integral, that's just on there, or just the actual like.
You're not about to do like.
So it'll all be on there. Yeah.
But what does this even mean?
We have to
You do know what that means. That's just the power rule and derivative of a constant. Me? I know, I didn't have a teacher that made me force me to.
Well, let's do the middle one.
I don't know, I struggle sometimes with some of those string ones, bro.
Can we do from cosine down? Or like because what is that? That's what we are. Can we pick the one?
These are the easy ones, bro.
No, she said we had to do it.
No, not calculus. I just started doing calculus.
Yeah, what is that?
I had to go back and relearn it. Heck yeah. No, I had to go take a class. You have to be certified to teach it. So I had to do a 2-week crash course.
It literally is constant and zero.
The College Board. Heck yeah. I was nervous. And you know what I did? I had to drive to Coastal to do the class, and it was 2 weeks long during the summer. And I had flashcards with those things on them that as I was going down the interstate on the way there, I was trying to look at those. Like I had them up on my steering wheel going, okay, trying to. Well, but I went through it. No, don't do that. Yeah, we had to take the AP F5. But everybody else in that class, like we did the whole course in 2 weeks. He did a crash course in 2 weeks. And one of the days was like the representative from the College Board there talking to us about stuff. But yes, it was intense. But everybody else was there, like, I mean, they stayed there and had like these crash course studies, and I was like, dude, what are y'all doing? Like, we have degrees in math. You should be able to do Calc 1. This is ridiculous. I mean, I just had to remember. I had to look and see it again. But how do you teach high school? And they couldn't even do the algebra behind the calculus. And I was like, that's why y'all are struggling, because y'all don't know what y'all are doing. I'm telling you, I think algebra is the key to success in calculus. All math, yeah. All right. After I recorded my whole rant there. Yes. Yes.
Like exactly that picture.
Does it not need to be like that?
No, it does.
I'd rather have some of it. Don't do the integral.
If I need to find the area between these two curves,
I don't.
tell me.
You just factor over and break.
Yeah, you just got f of x and g of x. So I want to know the area from here to here. So I'm talking about this shaded region.
Oh, find the area between that and the ground. Not the ground. Sorry, I'm being serious. Subtract that one right there.
You're actually right. You're right. I know what you're saying. You're getting it right, actually. But it's not. But in a nutshell, I'm gonna go from A to B, and then you always do top curve minus bottom curve. We haven't done with two functions, no. But essentially, subtracting the bottom one, we're kind of making it positive. It gets into all that, but this is just the easy way to remember. It's always, always, always top minus bottom. If you remember that, you will be okay. Without getting into the deriving it of where it comes from, how it is, why it is, top minus bottom on your integral, and you're good to go. Tomorrow we'll get into some ones that overlap, and at one point one's on top, and then you hit a certain point and the other one's on top, and you have to flip them into two integrals. But we'll get to that tomorrow. For right now, we'll just focus on basic, just top minus bottom, and it will give you the area in between. So area between two curves, top minus bottom. Easy enough? Let's do one example and I'll shut up. That's literally, yes. These do get hard, but I don't get hard than that.
Wait, can I ask you if it's going to be in the same order?
You have to graph it to see. I'm
No, I'm talking about the derivative. Stop worrying about that, right?
Got it? Might say wait. I'm gonna do a different equation. In your homework tonight, these will all be graphed for you. You won't always be that lucky. Find the area between the two curves. And let's even say you got to figure that out. Now here's the hard part though. I don't know what area. Okay, I know what this looks like, right? And Lainey says she knows which one's on top and which one's on the bottom. And I agree, that would be easy because I know that this is an upside down parabola. This is a line with a negative slope. So the area between the two is going to be like this. Do you agree? But it's an area between the two curves. So it's got to be sandwiched between the two curves. So there's only one area that's completely bounded by both curves. But how are you? That's what you got to find. That's the hard part, right? How do we know A and B? How? Set them equal to each other. That's exactly right. Where they equal each other are the points they share. Do you agree? If it's a point on the line and a point on the curve, that means it satisfies both equations, right? 2 minus x squared equals negative x. Find the points of intersection in the bound. Now, if you have a calculator, this is easy because your calculator will find it for you. Second trace intersect. But if you don't, you got to do it by hand this way. They would have to say, find the area between the two curves from bleh to bleh. Yeah, and they will. They will. So 0 is x squared minus x plus 2. This is a factor problem, and I know that I should get two solutions because it's intersecting in two places, right? So x minus 2, x plus 1. I'm only worried about the x's because that's how I measure my bounds, right? Is by what x here comes in. Yeah, sorry. I factored it right, but wrote it wrong. I was going too fast, sorry. It was a minus. I took it into account when I factored, but I just wrote a plus. Well, what I would do, and I always be careful, always label your graphs, and it seems very simple right now, but it's hard to remember what's what whenever you look. This is saying it intersects at these 2 points, yes? So all I have to do, those are going to be my bounds, right? So from -1 to 2, and I always do top, which one's on top? Yep. Minus, which one's on the bottom? negative x, and all this is dx. And now I just evaluate the integral. So you cleaned it up a little bit. Yes, you can, because remember we can split up plus and minuses. So you could do the integral from -1 to 2 of f of x minus the integral from -1 to 2 of g of x. Is that what you're talking about? Yeah.
Yeah, I don't really get,
Yeah, you will.
oh, this is what you do. So what was the point of you going through, find the bound?
Yes. I need to know what to go from. So at this point, I don't know what the y is, but the x is -1. Here, I don't know what the y is, but the x is 2. So I'm going from -1 to 2. And now I can just clean this up a little bit and say plus x dx. And now antiderivative. So 2x minus 1/3 x cubed plus 1/2 x squared. And all of this I'm evaluating from -1. Just tell you the answer. Plug in 2. And I'm going to plug in -1. Uh, 4 minus 8/3. 1/4. Right? -2 plus 1/3 plus 1/2. I don't know what this comes out to be. Sorry. Let me put this in my calculator. 4 minus 8/3 plus 2 minus -2 plus 1/3 plus 1/2. I got 9/2. Let me just show you quickly if you have your calculator how easy this is. Now, you won't have your, of course, tonight's a non-calculator, but you can always check. But I do want to remind you how to find intersections on the calculator. Real quick. This, by the way, is what that would look like on the graph. I'm fixing to show you how to do it though. So let's do start. I'll graph both of them, 2 minus x squared and negative x on the same graph. 2 is in 6. So remember, I first need to find the intersection points. So I'm going to go second trace, intersect. If you take your spider close to where the intersection is occurring, and then just hit enter, 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 that happens at -1. Same thing on the other. Yep.
I thought you put it on the intersect. You put it like down.
It just somewhere near. I just got to be closer to this one than this one because it's got to know which one it's calculating. So in other words, now I'm a little closer to this one, and it doesn't matter where. I mean, okay, it doesn't matter. Just closer, and you don't have to scroll or anything. Just enter, enter, enter. Close. Yeah. Yep. Second trace, intersect. Whichever one you want, just kind of take your spider close to that intersection point. It doesn't have to be on it. It doesn't have to, I mean, just near it. And then hit enter 3 times. 1, 2, 3. That's not the answer. That's finding my bounds. Yeah. That's finding your bounds. Yeah.
Oh, wait. Never mind.
Now, if I want to use my calculator to find the area between the two curves, I would probably come in here. I probably wouldn't do it on the graph that way. I'd probably come here and go math and go down to integral. And instead of y1 here, I'm going to do top minus bottom. So I'm going to do, which one did I put in first? So y1 minus y2 with respect to x, and then I'll do my bounds from -1. We actually did. We did it. If you've got the fancy calculator, yours comes up looking like this, right? Here, these are your bounds, and here you'll do y1 minus y2. Vars, and then scroll over 1. All right, let me give you what I got for you. Comma. Actually, put those in parentheses also. Put another set of parentheses around those. Comma x, comma, and then do your lower bound, comma, upper bound. Those are multiple choice. And then I'm just going to give you 1 or 2 little areas. It's not a lot. This is not the right page. It's that page 399. All right, we're just going to do, what did I have before? 1, 2, 5, and 6. Just do 1 and 2.